This is our summer math, week 3. Evaluate each expression. 2 minus a negative 1. Recall when we have subtract a negative, we will keep the first number the same, change our subtraction to an addition, and change the sign after. You may have used the mnemonic KCC, keep, change, change. 2, the subtraction changes to an addition, and negative 1 changes to a positive 1. 2 plus 1 is 3. Taking away a negative 1 is the same as adding 1. Right. Negative 7 plus negative 6. When the signs are the same, we simply add them together and keep the sign the same. 7 negatives and 6 negatives is 13 negatives. This makes sense. Think of a negative number like one money. If you owe $7 and you owe $6, don't you owe $13 total? Okay. Number 5, negative 7 minus 2. Again, keep the first number the same. Change our subtraction to an addition and change the sign of the second one. Positive 2 becomes negative 2. 7 minus 2 is the same as negative 7 plus negative 2. When the signs are the same, we simply add them together and keep the signs the same. 7 negatives and 2 negatives is 9 negatives. Find each product. Multiplication is very simple. If the signs are different, the product is going to be a negative. 6 times 10 is 60, and negative times a positive is a negative. When the signs are the same, the product will be positive. 2 times 9 is 18. A negative times a negative is a positive. We don't have to indicate a positive, but we might. Positive 18, that's equal to simply 18. Solve the equation. An equation is 2 expressions with an equals in between. We're looking to find the value of k that makes our statement true. We use inverse operations. This is negative 6 times k. Connected implies multiply. We will undo multiplication with division. It's inverse. Dividing by negative 6 on both sides. Negative 6 divides negative 6 to leave k. 84 divides negative 6 to be a negative 14. Again, a positive divided a negative will be a negative. We could take this negative 14 and substitute it back in. I'll show that. Here we're simply checking negative 6 times, instead of k, we'll substitute what we think k to be, which is negative 14. Question, is that equal to 84? Well, negative 6 times negative 14 is 84. 84 is equal to 84. This statement's true. So this tells us that k equal negative 14 is a solution. It's a value that makes the statement true. Alright, here we're going to solve for v. We see v has 1 subtracted from it. The inverse of subtraction is addition. I'm drawing this line just as a separator to keep whatever we do to one side we do to the other. You don't have to draw it, you can if you wish. Minus 1 cancels with plus 1 to leave v. Minus 5 plus 1 is a minus 4. I could take this value of v and substitute it into my original. Negative 5 equals, instead of v, we think v is negative 4. Minus 1. Is this true or false? Yes, it's true. Negative 4 minus 4 is a negative 5. And negative 5 is equal to negative 5. This is true. So that tells us that v equal negative 4 is a solution. In fact, the only solution. Right, we want to solve for k. We will first deal with this minus 5. Using the inverse operation, we will add 5 to both sides. Minus 5 plus 5 sums to 0, leaving just k over 6 on the left. Minus 7 plus 5 will be a minus 2. Here we have k divided by 6. The inverse of division is multiplication, so we'll multiply by 6 on both sides. Multiplying by 6 on both sides. Connected means multiply. Negative 2 times 6 will be a negative 12. The 6 cancels with the 6 to leave k. K is a negative 12. We could take that and substitute it back in. It would satisfy our equation. Here we have negative 6 times this parentheses. Again, connected means multiply. We will employ the distributive property. We simply multiply the negative 6 by both terms inside. Negative 6 times x will be a negative 6x. Negative 6 times plus 2 will be a minus 12 equals negative 132. We're solving for x. We will undo our minus 12 by adding 12 on both sides. Minus 12 plus 12 goes to 0, leaving negative 6x on the left. Minus 132 plus 12 is a minus 120. Solving for x, we'll divide by our coefficient, that number connected, dividing by negative 6. Negative 6 divides negative 6 to leave x. Negative 120 divided negative 6 is a positive 20. Let's show our substitution, substituting 20 in place of x. So negative 6 in place of x goes our 20 plus 2 equals negative 132. That's our question. Is this a true statement? Notice from here to here, I just changed x to 20. X became 20. That was it, because we think x is 20. So 20 plus 2 is 22. Times our negative 6. Well, that is indeed negative 132. Negative 132 is equal to negative 132. This is a true statement. So k equal 20 is a solution. One last problem. Solving for v, we will begin by undoing this plus 8 by subtracting 8 to both sides. Whatever we do to one side, we do to the other. 8 subtracts 8 to leave 9v equals in the middle. 26 subtract 8 will be 18, dividing both sides by 9. 9 divides 9 to leave v. 18 divided 9 for 2. We think v is 2. I could substitute this by can. Let's do it in our head. 9 times 2 is 18. Plus 8 is 26. So v equals 2 is a solution. That concludes this video. I wasn't recording them. Spitfire. I was not. I am.